So we have number 7 from 12a. So in a certain world, the maximum running speed, which is v, of one organism is dependent on its number of toes and the number of eyes. Okay, and the relationship is given with this equation. And in a population where the organism have a 5 toes, we have this equation. Okay, so let's use that first. We have the equation v is equal to k times n to the a times m to the b. But when you have the 5 toes, which is n is 5, so you can just replace this by 5, right? So you will get like the v is equal to k times 5 to the a times m to the b power. But we are told this is going to be equal to this one, which means we actually took the log of both sides. So we are going to take the log of v and the log of everything on this side. And a reminder, when you guys have a product of the product of things in the argument, we actually can split those as sum of logs, which is one of the properties. So that should be equal to log k plus the log base, 10 of 5 to the a, plus log base 10 of m to the b. But the form that we are given has no exponent. So another property was if you take the power and then you can pull inside. So let me just write the properties just real quick, just to kind of refer. So like when you have the log x, let's say base a times b, and then I just write 2, but you can have more than 2. This was equal to log base x of a plus the log base x of b. Again, ab is just 2, but we can make this more. And then another property is if you have something y to the, let's say, k, and then the k is the power of the argument. So in this case, you can take this power k as product of the log base x of y. So that's just another property we are going to use now. Okay, so then with that in mind, so we can just write this as the log k plus I can take a in front, so you should get a times the log 5 plus b times the log m. And then we are told that is equal to 4 plus 2 times the log m. So in order for them to be equal to each other, the number in front of the log m and the number in front of the log m has to be the same. So which means b and 2 has to be equal to each other. So the b is 2. And you don't really care about the rest because the 4 is just going to be equal to some of the leftover. So which you can just write it, but they are equal to each other, but there is no need to use that for now. And the next one we have is if you have 25 eyes, which was m is 1 eyes, we got this equation. So let's use that as well. So the log v, I'm going to just kind of skip this process. So you get the log of this guy, so you log k plus the a will be now in front, so you get a times n, which is log n. But in our case now we are looking for the i's, which is m will be replaced with 25, so that should be plus b times log 25. So this is exactly what we did right here. I just skipped one step. And then we are told this is equal to 4 plus 4 times log n. Log n. So the coefficient of the log n is a. Coefficient of the log n is 4. So that means a has to be 4. Okay, so we got a and b, which is cool, but we don't know missing the next variable. So let's try that as well. So what we have like 25 and 5 is given, right? So maybe we can use 25 one. So when you have 25 like i's, which basically the m is 25, right? So we can just plug those into one of the equations. So let's use that. So the log v was equal to log k right, plus a times log n, and then plus b times log 25. So this was equal to 4 plus 4 log n. Okay, so from here, so we know the a is 4, so we can just say the number right here is the same as this one. So we got a is 4, and then b is 2. So like maybe we can plug those. So what we have now is basically log, I'm gonna say this is 4, right? So this is 4, so these will cancel. So you will get the log k plus b b times log 25. And then b was 2, but I can pull that as a power, so you will get just the log 25 to the b power, which is the second power. And then this is equal to log v. But you know the log v was something we already have, right? That was 4, right? So that should be equal to 4. And then the rest just property of the exponent. So we have this k and this is 5 squared, which is 5 to the 4. You can multiply those. So you get log base 10 of 5 to the 4 times k as my argument. So this is equal to 4. Okay, so that is something, right? So then we want to find the k, but this is like I can take this as like 10 to the 4th power is equal to 5 to the 4th times k. Since you know this is 2 to the 4th and 5 to the 4th, so that 5 to the 4th will cancel, k will be 2 to the 4th, which is 16. So that will be our k, that's what we are looking for. So the 16 and 4 and 2, so it looks like we have 22. Okay, so that wasn't too easy, but it wasn't too bad either. As soon as you write the given information into your equation and use some basic properties of the logarithm, so you get what you want. Okay, anyway, I'll see you in the next video.